Do we start? Okay. So we'll do a quick talk about why and how in Xamarin Forms we compile XAML into IL. It's actually very similar to the talk that Andrea did earlier this morning, where she transpiled TypeScript into IL. You'll see a very similar pipeline, very similar concept, but it's in the context of compiling XAML5. We'll come back to that into IL. But also this concept could be used to compile any resource that needs to be interpreted at runtime. I'm doing this talk as well because that's one of the black box of Xamarin Forms. Very people know how this works. Very few people know how to contribute to this part. And we're just scratching the surface, but that will explain you how it works. So I'm Stefan. I work on Xamarin Forms since 2013. Prior to that, I'm using and contributing to open source since before 2000. I've been a contributor and maintainer on Netspot. I've been a contributor on Moonlight, on Mono, on some other open source projects as well. You can reach me on Twitter or on GitHub. So by saying that I work on the Xamarin Forms since 2013, I'm at Microsoft for the past 2.5 years when Xamarin was acquired by Microsoft. So Xamarin Forms, Miguel isn't there to correct me, so it's fine. Xamarin Forms is a framework to create, at first, mobile applications, and you build your application once, and then you deploy it on any of the supported target, and the application will be native on that application, on that platform. Over here you see iOS, Android, and it might still be WP7, or it could be UWP. I don't remember which. At which time we took this picture. So those were the main targets for Xamarin Forms. At this time, we support deploying Xamarin Forms application to iOS, Android, macOS, UWP, WPF, GTK, Tizen, GUI.cs, so the one you saw earlier, and probably still a few others. So at Xamarin, we maintain the backend for iOS, for Android, for UWP, for Mac. All of the other backends, WPF, Tizen, GTK, are contributed by the community. So Tizen, if you don't know Tizen is the OS that runs in your Samsung TV or in your Samsung dishwasher. So if you want to run an application on your dishwasher, it will be a Tizen one. Tizen also supports some wearable devices. So this is Xamarin Forms. Who is using Xamarin Forms? Great. Yeah, but I know those guys. Okay, so Xamarin Forms, if you see this, all of those controls are native to the platform. So this is an iOS map. This is a Bing map, and this is a Google map. But the code that runs that is exactly the same. Everything is native at the time at rendering, and we create a UI either in C#, in F#, or in Xaml. What interested us at this time is Xaml. Xaml Informs is also open source. It hosted on GitHub, so it's open source almost since, I think we open sourced it a bit before being acquired by Microsoft. So it's been open source for the past 3 years. We get a lot of external contributors. The community is great. It happens on GitHub. You'll see the GitHub address a bit later. So this is a very simple XAML file. Who's not familiar with XAML? No? Okay. So XAML is just a descriptive language. It's not a programmation language, it's just a descriptive language that can create objects and assign properties. So there is no conditionals. It's not a Turing complete language. It's just a declarative language. And in this case, we just create it. It's a subset of XML. I mean, it's XML. It's XML compliant. So XAML is just XML. So you define a content page. In the content page, we define a stack layout, and in the stack layout, we define a label with a text, and that text is bound to a property of the context. So that's XAML. When you see this, basically you've seen most of what XAML is. So it's just quite simple. What we used to do on XAML Informs is taking this XAML, shipping it as an embedded resource in the assembly, and at runtime, when the view had to be inflated, we were extracting this resource, parsing it at runtime, parsing it to an AST, and then expanding that using reflection, so it becomes a full object tree. So from that, we turn that to actually an object, which is a content page that contains a stack layout that itself contains a label with a binding. So you could write the equivalent of C# code for that. It would take something like 15 lines. The problem is, if you come back to the previous slide, on the middle there was an Android device, and Android devices are quite diverse. You have probably the DIN that the guys over here have in their hands. Those are Samsung, those are LG, but there is also a full set of devices in Android that takes something like 60% of the market that are low-end devices, something that costs less than $100 or that have been bought more than 3 years ago. And those ones are single core, old core, very few memory. And when you start doing parsing of big files on those, using reflection on those, creating tons of objects because you need objects, and then garbage collecting them, you end up with quite bad performances. Meaning that for large XAML file, turning that XAML file into an object tree could take a few tenths of milliseconds, like 60 or 70 milliseconds, just to interpret the input and having an object tree, which is not yet at this time rendered on screen. So that's 70 milliseconds, or 60, or it depends on the device, that were just lost, on which that was not compressible time. Yeah, the main reason for that is the main problem for that the parsing at runtime manipulation using reflection is performance on Android. So as we are a mobile application most of the time, 99% of the time, are self-contained. By self-contained, I mean that all of the assets are already part of the application itself. Yeah, it can connect to external servers, but most of the views you would in another application that's not Xamarin Forms, you would write it in XML in Android, you write it in Swift or Objective-C in iOS, and so why? So everything is known at the time of the compilation. So we could technically, it's not everything that we know at runtime is also known at compilation time. So why not keep the capability of writing XAML files, because XAML is a great way to describe UI. Why not keep this capability, but turn that into something that is actually compiled and as fast as if you have described your application using C#, C++, Objective-C, or whatever, and be actually compiled into the assembly. So we can do that, and that's an advice that you have to use for all of your mobile application. If you have a resource, if you can do something at compile time instead of at runtime, you have to do it. If you have an image and that image needs to be resized, it's better to resize it on your computer time at the time of creating the application instead of resizing the image at the time of rendering. If you know the size it will be rendered at, resize it before, because everything that's done on the device is done a million times instead of being done once on your machine, and it's done on some low-end devices. Yeah, I know that if you have a top of the range iPad, it's probably more performant than this laptop. But that's not the case. I mean, it's the case for us in this room. It's the case for people in the West, but it's not the case for the rest of the world, most of the world. And the target, the big market for the mobile application right now, the market for expansion, the market the people that need applications is it's Africa, it's Asia, and if you go there, you don't feel developers with the same privilege that we have over here in Europe, in the US, and they don't run with the same constraint. So we need to think about the performance. We need to test our device or application not on our personal devices. We need to test them on actual devices used on the field. So what do we do? So how do we achieve that, compiling XAML into IL? So we have that XAML, that's exactly the same as before. And we pass that to an AST. An AST, yeah, is just a tree. It has a content page. The content page is a property content, which is a stack layout, which is a property children. And the children is actually a label, which has a name and a text. This is actually exactly the same parser as the one we used to use at runtime, Xamarin Forms. It passes to an AST. And then on the AST, we run a few visitors. So we implement a visitor pattern, and we go on all our nodes and do some stuff. For working on trees like this on EST, visitor pattern is often a really good one because you can walk the tree multiple times without modifying it. And so we have everything in all tree is an inode, and we have some visitor that implement the node visitor. So the most important one in this case, because I told you Xaml is a language for creating object and assigning properties. So we have a create value visitor, and we have set properties visitor. So that's what we do. So we at first create all the objects, create the content page, create the stack layout, create the label, create the object that will be set, create the binding, and then on the second pass, what we do is setting the name of the label to label, setting the text to a binding, setting the content, the children of the stack layout to the label, and setting the content of the content page to the stack layout. And we do that using MonoCecil. MonoCecil is an awesome library that generates and inspect assemblies. So it's used, for example, at Xamarin, we use it for the linker. The linker is the tool that you run on a fully built application, and that will remove all the stuff that you don't need. And again, if an application is fully contained, you can follow every pass, and you can find that this function, this class, this type, this property is never used, except if it's used by reflection. In that case, we don't know. You have to mark up. But we can remove everything, and we can reduce the size of an assembly. That you might think that you do not write code that's not used, but when you write code, you depend on MS-core-lib if you write a C# application, and you don't use every single function of that MS-core-lib, so you don't have to ship it. So Cecil does that. Cecil has been around since 2004, and it's done by our friend JB. JB, yeah, a few years ago he was living in France, so he was coming to FOSDEM every year, but not anymore. He moved to Seattle. So how do we do it? So I told you that we are generating IL. This is the IL we generate for the example. The example I've just shown you. So this is the IL. This is the equivalent decompiled C#, if you know C#. So we create the binding extension. The binding extension is the markup extension with the curly braces. Binding. We create the label. We create the stack layout, and we store every single of them in a variable. Binding layout, stack layout. We do that. What time is it? Okay. And then we set the properties exactly with the IL. So this is the code we generate from our XAML to IL compiler. So, and this is quite equivalent to the C#. So we set the text as the pass property of the binding. We set the text to the pass property of the binding. It's over there. We set the binding to the label. The label is the variable 1, which is over here. We add the label as a children of the stack layout, and we then set the value content to the stack layout, and then we return. If you look at the number, we are quite high because there are some other visitors that generate stuff. Those are for the ability of names, for the ability of name scoping. So you can do find name, maintaining state, and so on. So it's a bit more complicated than just that, but this is the gist of it. It's the minimum requirement, and then yeah, we need to support some more complex when you have references between parts, and that's why it gets harder. on performances, it compiles XAML faster than the equivalent C#. So XAML is slightly less verbose than C#. So if you have to write the same code in C# that you would write in XAML, you would have 3 to 5 times more C# code because all the binding is done automatically. We most of the time create the object and assign the properties on the same line, something that's not done usually in C#. So this is a run that I just did this morning. So my laptop was on the power reserve. So it was on. Those numbers are the order of magnitude is right. The number are not describing the reality. But basically, the XAML C for 1,200 lines of XAML took 3 times less than the number of C#. And if you multiply that by 3 or 5, you end up seeing that we are a bit faster than Roslyn. We are on the same order of magnitude as the old monocompiler. I think I've missed something. Okay. Yeah. So the runtime performance is totally worth it. We are inflating the view really fast. Most of the time we inflate the view, so we turn the XAML. Not the XAML because the XAML isn't ship anymore, but we just construct the object in a few milliseconds. We also, I haven't shown you that nor explained, but if you take this is a markup extension. It actually can get compiled just like all of the markup extension. And by doing a compiled binding, if you know what a binding is, it's a way to link between your view and your view model. And most of the time we do that by reflection and by connecting via reflection to identify property change. But if you know the type of the view model at compile time, you can actually create a function that does that and cut the reflection from it. And so we have a boost up to 200 times on bindings. So bindings are known to be not that fast, and that's the case in most languages because they are syntactic sure, they are convenient for the developer, but they are not known to be fast. But if you manage to keep the syntax of the binding and turn that into actual code at compilation, you get the same performance that if you were observing the object yourself. So if you want to know more or contribute to Xamarin Inform, it's on GitHub, Xamarin/Xamarin-Inform. And that's it. Do you have any questions? Yeah.
Essentially, you said at the beginning, sort of beginning, about the image, if you want to resize it ahead of time, etc. Was that just a simple example, or is that like one of the things that's actually like the reason I ask it actually is I'm immediately thinking, but we don't know the resolution ahead of time depending on device.
Depending on device, but if you know, do it. If you don't, it's probably. But images was just an example. You could compile if you have huge JSON file that you ship to your application. You can think of a way to pre-process them because those are stuff that are expensive to process at runtime. And image was one of the example. But yeah, most of the time you don't know the exact resolution, but you know. If you have telemetry on your application, you probably know what are the 10 most known size, at least for icons, and some of the image, not the image that take full screens, but most of the time, those one you don't ship them with the application. An image that takes full screen, except if it's a background. You don't ship it. It's downloaded from a web service. It's stored in your local storage for your application because you're doing a photo application, you're doing a news application, and for those one, there is very little we can do. But most of the time, that's a single image on a page. But if you have a UI that you fully drawn with images because you have a button, you have a pen, and if you don't pre-process those images, you will pay the price. And if the customer experience matters to you, and it should, so you should really measure what takes time in your application and see where you can. That's free time. That's really free. Other question?
How can you make sure that your bindings are compiled? You're a developer, Xaml imports. How do you?
In the case of the sample, we have some blog about it, but to be able to compile the bindings, we have to. We are the Q&A. Thank you. For the XAML compilator to be able to compile bindings, you have in your XAML to tell this is the expected type for the view model. And so we know that. It was way out of this 30-minute introduction to compile XAML. So, but we have some blog from David about it. So you just tag it at the eye level, and you tag it at the list view level, so you know that for your data templates it will be this, and we can compile everything. So we are still. This is actually shipped for the past 2.5 years. It's been enabled by default for the past year and a bit, but we are still working on it. We're still doing more and more compilation and less at runtime, just to save time. Question?
So just to reiterate, so practical examples were a GSOL and image?
Yeah, for example.
Yeah. And would there be any online source that you would recommend to learn these kinds of things? Like where I could learn more?
I don't know. I would say just measure everything.
Okay, that's good. Thank you.
You found something?
Sorry, I have yeah, sorry.
So, where's our next speaker? Oh yeah, I have some money to give back to you. But where's our next speaker?
Sorry?
Yeah, I'm missing a speaker.
I am.
Okay. How does this clip work? Ah, there we go. Hi.
Are you Michaela?
I am.
Hi, Michaela. I'm Steve.
Hi. Nice to meet you.
Nice to meet you. I guess it's fixed. Do we have a level somewhere that we can see if it's good or not?
I
Or
have not seen anything.
okay, well, hopefully it's okay.
Occasionally one of the AV people comes in and does some stuff.
Okay, I'll try not to touch
I
anything.
think there's like a couple of them, like the whole thing.
Got it.
So they just watch the feeds and.
All right, that's good.
So I will try and do a 5-minute warning.
Great.
And then count down on my fingers.
Okay, that's fine. Hopefully it'll be good on my iPhone as well. So.
Yeah.
Ooh, busy. Okay.
do to go to 330.